Section 3A, Roman numeral 1, 3 ways to use or represent percents. The first way is a fraction or part of a whole. The next is change of one item, such as stock price. And the next is to compare two different objects. The definition of percent is exactly how it is, a direct definition of per and cent. Now we already talked about per meaning divide. Cent, there's different ways to think about it. Cent, ciento, cien, cento, or cents. How many cents are in a dollar? Different languages, Latin-based languages, where it means 100. So the very direct definition means per or divide by 100. So if we take the number 10.4%, this really means 10.4 divided by 100. Or if you plug that into your calculator, you get 0.104. Another way is 10.4% of 100,000. Of defined is multiply. So this is 100,000 times the decimal or the percent, changing it to a decimal, 0.104, which equals 10,400. Let's move on to the next example. A newspaper reports 44% of 1,069 people either did or liked something or voted for something or other. How many people is that 44% of my 1,069 people? That's exactly what we want to look at, is the of part. 44% of. Of means multiply, so I'm going to change my decimal, 44%, to a decimal form of 0.44 and times it by 1,069, which gives me 470 people. Notice I've highlighted my answer so that it's set apart, and we'll move to the next one. We're now going to use percent to describe a change in something. The first thing is called absolute change. The absolute change, such as a population increasing from 10,000 to 15,000, is the absolute change, and I'll use this abbreviation, is 5,000. So absolute change means I'm going from exactly one number to the next number, or subtracting the later value from the earlier value. Relative change means I'm looking for a percent. Relative, from now on, every time you hear that, I want to think of a percent. Relative. So in this case, if I go from 5,000 to 10,000, that's a 50%, or the relative change. A reference value is the starting number. The new value, or the compared value, is the number that I'm comparing to the starting or the reference value. Here are our formulas for change, which means that I'm changing in one item, one stock price, or maybe one person has a change in height. It is one item. And I know I'm making a big deal out of that now, but if you haven't read the chapter, which you should have already, you'll remember that there's two formulas. One is for change and one is for difference. The difference is when I'm comparing two items, so when I'm looking at change, that is one item is changing in value. So here are two formulas. The absolute change means I take my new value and subtract the reference value or the starting value. I kind of like to think of it as the new price or the new value subtracting the old. I'm going to go ahead and highlight that one just a little differently. The next is relative change. Wait, relative means percent. Every time from now on, when you hear that, you think percent. This is when I take the new value, subtract the reference value, and divide by the reference value. I really like to think of it as the new minus the old over the old. That way, it's kind of easier. In other words, once you divide that, you can change it to its percent, but relative is always about percent. So we're going to move on to example D. Nokia's stock doubled from $10 to $20. Now, notice it's only one item, and it's increasing. Find the absolute change and the relative change. Absolute change, you just subtract straight up the new value subtracting the older value. So I have my new value, it's now valued at 20. So I have 20 subtract 10, the old value, or an increase of $10. The relative change, I use the exact same numbers, 20 minus 10, and then divide it by the old value. So 20 minus 10 is 10. 10 divided by 10 is 1, which is changed to a percent, 100%. Okay, and notice that I've also highlighted in some way that these are the answers so that they're set apart. So when you turn in your homework, I can easily find your answers. A lot of you could even go over here to insert and do a scribble and circle it in that fashion. It's up to you. Let's move to the next example. The world population grew from 2.6 billion in 1950 to 6 billion in 2000. Find the absolute and the relative change. Remember, absolute means new minus old. So my new number or population is 6.0 billion. The old population is 2.6. So subtracting 6.0 minus 2.6 gives me 3.4 billion. The relative change takes that subtraction, that exact same one, and then divides it by 2.6. These will match. And you get 1.3, or changing that to a percent, move the decimal over 2 to the right, makes it 130%. Remember, relative is always percent. A computer bought 3 years ago for $1,000 is now selling for $300. Find the absolute and relative change. The absolute change is the new minus the old. My new price is $300. The old price was $1,000. So new minus old is 300 minus 1,000, or negative 700. The relative change will still be 300 minus 1,000, but divided by the old value as well, which is 1,000, making this negative 0.7. Or, changing that to a percent by moving the decimal over to the right too, is negative 70%. You can be using your calculator for this, or you can also be using Microsoft Excel. I'm going to come in here and just type it in. Remember, to make it work like a calculator, press the equal sign, 300 minus 1,000, and then I want to divide that by 1,000. So I need to put that in parentheses. Oops. I'll go back and fix that. It said I didn't put the parenthesis on the other side. And then I want to divide that by 1,000. Press enter. There we go. If I want to change that to a percent, I can also format the cell. There it is. Format the cell to be a percent, and there we go, negative 70%. But you can use your calculator as well on these smaller problems. I'm just trying to get you familiar with Excel because you're going to have your very big projects coming up on Excel, and it's nice to have a little bit of background before you're thrown into the midst of it. Okay, our next example is using percents for comparisons, a comparison of two items. So the cost is $50,000 for a Mercedes and $40,000 for a Lexus. Find the difference. Notice it says difference and not the change. Change means in one item, difference, I'm looking at two. Difference as a definition has always meant subtract. So I need to subtract the two prices for the Mercedes and the Lexus. The Mercedes came first, so I'm going to subtract Mercedes minus Lexus, which is $50,000 minus $40,000, which is a difference of $10,000 in cost. The Mercedes costs $10,000 more than the Lexus. If I want to find the relative, I would do the 10,000 divided by the 40, and I get 0.25, and the Mercedes costs 25% more than the Lexus. So we are comparing the Mercedes to the Lexus, and so the Lexus is the reference value, and the Mercedes is the compared value. And the way I like to think about this is compare or compared will always come before the compared value. So comparing Mercedes, there you go. So the next one will be the reference value. And here's our formulas. And I highlighted my formulas up here to be red, so we'll stay consistent and make these red as well. So my absolute difference, not change, because I'm talking about two values now, will be the compared value minus the reference value. And remember, the compared value, it'll state in the sentence, comparing the Mercedes, so that's the compared value, to the Lexus, so the Lexus is the reference value. And you'll notice these look exactly the same as the one above, compared value minus reference value, or in our first case, with one item, it was the new minus the old. Then the next one is compared value minus reference value, and it's still divided by the reference value. These two should match, just like in our other one, the old and the old matched, or the reference value and reference value. All right, let's go ahead. And I just discussed how these are the same as our previous formulas, but we're using two. So the absolute difference, if I compare the Lexus, so the Lexus is now the compared value to the Mercedes, so the Mercedes is the reference value. So I'm going to compare the Lexus compared value, 40, minus the 50 for the Mercedes, gives me negative $10,000. Or the relative difference is still the compared value minus the reference value over the reference value. These should match, and I get negative 0.2, or changing that to a percent, negative 20%. And we can state the Lexus costs 20% less than the Mercedes, or we can state also that the Lexus costs $10,000 less than the Mercedes. So we have two different ways of interpreting that with the absolute difference and the relative difference. Let's move on to the next example. The cost of living in Connecticut is $48,328 per person versus Montana, which costs $26,907 per person. Let's compare Montana to Connecticut. So I want the absolute difference, not change, and the relative difference. Now I want to compare Montana. So Montana is going to be the compared value. Compared value comes first, minus the reference value. Montana is 26,907, so I'm going to take that, subtract Connecticut, 48,328. That's down here. You can use your calculator or go into Microsoft Excel and just type it in. I'll get negative, and I'm going to put a dollar sign in here because we are talking about money per capita, $21,421. And if I want to interpret that, I would say that Montana costs $21,421 less per person than Connecticut. The relative difference, again, I take this subtracted value, and in this case, I'm not going to subtract it again. I can just stick that number because I've already subtracted over my reference value, which is the second value, or 48,328. Dividing those gives me negative 0.443, or the percent, negative 44.3%. And again, I've made my answers a different text color, just some way to make it stand out. And there's my interpretation. Montana costs $21,421 less per capita than Connecticut, or you can state Montana costs 44.3 or 44% less per capita than Connecticut. The next part gets a little tricky, the of versus more than. Of meaning times, more than means add. And you can kind of think of it in a simplified term, which we learned how to do when we did problem solving. If I want to simplify something in my head, I think of meaning multiply, more meaning add. So if I have half of the value of somebody else, I take that value and divide it in half or times it by 1/2. If I have 5 more apples than Sarah, then I add 5 to the same number that Sarah has. So more than means add. In this case, we're going to go a little bit more, I guess, college level. If a population increases from 200 to 600, we can state that it is 200% more than the original population. Or we can say that it's 300% of the original population. So let's kind of go through why it's more than versus of. 200% more than. Now, if I want to double something, 100% is that same value added on top of it, which is doubling. 100% is doubling. So if 100% of the original is 200, 200% is twice that, which is 400. So 400% to go from 200 to 600. So 200% more than the original. 400 plus 200 is 600. So more than was add. Of means multiply. 300% of my original is 200. 300 changed to a decimal is 3. Of means multiply. The original is 200, and we wanted 300% of the original. 3 times 2 is 600, and it gives us the answer right there. So of means multiply, more than means add. Here's a couple of formulas that'll come in handy. If a compared value is p% more than the reference value, and I like to use my abbreviations, I have 100 plus p of the reference value. So the compared value equals 100 plus p% times the reference value. So notice I have the addition sign in here for the add. Now if I have the compared values p% less than the reference value, I take 100 minus p% of the reference value. Less than means minus. So that's where we see it. And I know a lot of you might be thinking, well, I thought you said of means multiply, and that's where the of here becomes the multiplication here. So if a compared value is p% more than, I add and then multiply to the reference value to find the new compared value. And less than, you subtract. A good way of thinking about this is if you go shopping and you find, let's use this one for a sale. If I have a compared value and a reference value, and I have a 25% off sale, I could take 100% or 100 minus 25%, and I pay 75% of the price. In years past, or probably in past math classes, you took the price, you timesed it by 0.25, and then you subtracted whatever that was from the original. In this case, you save yourself a step by saying, if it's 25% off sale, then I'm going to pay for the 75%. Okay, Carol earns 50% more than William. How many times larger is her income than his? So 50% means that I need to add 100 plus 50, because it's more than, of William's income. Changing that to a decimal is 1.5. That is what I times to William's to get how much Carol would earn. Oh, here's our 25% off sale. Comparing the sale price to the original price. And I'm not going to go very far because we already talked about it. Oh, there's the answer. So if I have a 25% off sale, I do 100 minus 25, and I pay for 75% of the original price. Percentages, remember of means times. Suppose your bank raised your interest rate on your savings account from 3% to 4%. So your APR rose 1 percentage point. It did not raise 1%. If it were only 1%, then it would be 1% of the original rate, which is 3. 3 is 0.03. 1% is 0.01, so it'd be 0.01 times 0.03, or multiplying those together gives you 0.0003, or 0.03%. It's increased by 0.03% from 3% to 4%. It did not increase 1%. If I want to state that, I must say 1 percentage point. So let's find let's find the relative change of what we went from 3% to 4%. So the relative change, remember relative means percent. The new value minus the reference value over the reference value. My new percent is 4%. The reference value is the starting number, 3%. And then divided by the reference value, or the old number, is 3%. Or you can think of it as new minus old over old. 4 minus 3 gives me 1 percentage point, or 0.01, divided by 3%, which changed to a decimal, is 0.03. Dividing 0.01 divided by 0.03 gives me 0.33, or 33%. So it was an increase of 33% to go from 3% to 4% for my APR. Now over here, this was telling us if it rose 1%, it would only have increased 0.03, not increased up to 4%, but it was an increase of 33% to go up to 4. All right, let's move to the next one. The percents of adults reading the newspaper fell from 78% in 1980 to 49% in 2009. Find the absolute change and the relative change. Remember, change means I'm looking at one item changing in value. In this case, it's the percent of adults who are reading the newspaper. The absolute change is the old, or is the new minus the old. The new is 49% minus the old, which is 78%. 49 minus 78 is 29 percentage points, because I didn't find a relative change here. If I want to find the relative change, I still do 49 minus 78, but then I divide it by 78, which gives me negative 0.3718. Changing that to a decimal is a drop of 37.1% in the reading. Now I'm going to hurry. I don't know how many of you are familiar, and I've been doing this the whole time if you've been following all the lectures, but if you're new to this lecture, I'm going to hurry and jump in here and insert an equation for those of you who might be new to it, so you know what I have down here on the relative change. So my relative change, I'm going to do a fraction because it is the new value minus the old value. The new value was 49%. Subtract the old value is 78%. And I push the down arrow button or the over to get 70, or down to the bottom and put in 78%. Press my over button to get out of there. Equals. And I have all of my tools up here. I don't need to press equals anymore. We're good to go. Okay, let's move on to the next example. Before we get started, note that 40% of the registered voters are Republican in Carson City. So our first part of example B is the percent of voters registered as Republican is 25% higher in Freetown than Carson City. What percent of registered voters in Freetown are Republican? So it is 25% higher in Freetown. 25% of 40, because it was 40% of registered voters in Carson City. So 25% of my 40% is 10% higher, 10 percentage points higher than the 40% of Carson City. So I add my 10 percentage points, gives me 50% are Republican in Freetown of registered voters. Let's try the other one. The percent of voters registered as Republican is 25 percentage points higher in Freetown than Carson City. 25% percentage points. So I don't even need to do really any calculations. If it's 25 percentage points, I add it simply to the 40 and get a 65% of those in Freetown are Republican. Okay, Roman numeral 3, solve percentage problems. I'm going to make these red just to be similar to our previous formulas. Retail price, or the compared value, equals 100 plus p percent of or times the wholesale or the reference value. And rewriting that by dividing both sides or solving both sides for wholesale, I'll have the wholesale price is the retail price, which is the compared value, over 100 plus p percent. Note we can also do 100 minus p, which we can do when we do our sale items as well. This one's kind of tricky. A lot of people get the second one wrong. So we're going to go through it step by step. A shirt is $17 before sales tax. If the tax rate is 5%, what is the final cost? Most of us are okay with this one, and sometimes you use your old knowledge of just timesing it by 0.05 and adding that to 17. And you can do that. But to save yourself a step, if I have 5% for the sales tax, 100% covers the cost of the shirt, or $17. 100% of $17 is the cost of the shirt. Plus, now I have 5% of that cost for the sales tax, so I end up paying 105% of the wholesale, which was $17. So 105% times 17, or changing that to a decimal, is 1.05 times 17 gives me my answer of 17.85. And in this case, I went ahead and circled it using my shape and my squiggle, changed it to a red. There are some of you who might have an inking function where you can change and circle this way. It's up to you. Some way to define that that's the answer. The next one's the harder one. A lot of people get this one wrong in all of the work that they turn in, so watch carefully. You paid $19.26 for a DVD. That's what you paid at the register. That is what it's including the tax. The tax rate is 7%. What was the labeled price before tax? So I'm not looking for how much I need to pay on top of that. I want to see what the price tag said previously. So I'm looking for, in this case, the reference value. So I paid $19.26. That's my retail or my compared value, divided by what I ended up paying for in tax percentage. So I have 100% that I paid for the shirt or the DVD, and then 7 for the tax. 19.26 divided by 1.7 gives me $18. And a good way to check that is to go through and put the $18 in the previous formula. And I'm going to go ahead and highlight that. You can put $18 here for the wholesale, 18 times 100 plus 0.7. In fact, let's go into Microsoft Excel and try that. Making this work like a calculator equals 18 times, and I'm going to put a parenthesis for my 100 plus 7, and that's in a percent form. So I'm going to put percent equals, there we go, 19.26. Was that the cost? I paid 19.26. There we go. Let's move to the next example. The rate of 8th grade smokers is up 44% to 10.4%. What was the original percent? It looks a little confusing because this is higher, but remember, it's all relative. 44% of the original percent to 10.4%. So I'm going to use my compared value formula equals 100 plus p, because I was increasing percent, times the relative value. So I My compared value is 10.4%. I am increasing by 44%, so it's 100 plus 44 times the reference value. And I don't know the reference value, so I'm going to divide both sides by 144. Plugging that into your calculator or Excel will give you 0.0722. Changing that to a decimal is 7.2% for the reference value. So it increased from 7.2% to 10.4%. We can kind of think of it as 44% of 7.2, it's not quite half. So half of 7 is 3.5, and the whole thing is 7.2. So I'm not quite half. Let's go ahead and say 44% is about 3. 3 plus 7.2 is about 10.4. So we did it right. Roman numeral 4, abuses of percents. This is done a lot, shifting the reference value. So let's suppose you get a 10% pay cut, but later you get a 10% pay increase. Do you balance out back to your original pay? I don't know. Let's see. So let's just assume, let's just say you have a $200 a week pay. A 10% pay cut is 10% of your $200, or 0.1 times 200, which is $20. So you got a $20 pay cut. Your new pay is now $180 because we took 200 minus 20 is 180. And now you get a 10% pay increase. So a pay increase of 10% of your new pay, 180. 180 times 0.1 is $18. 180 plus your new raise of $18 is 198. That's not the same as your $200 that was your original pay. So no, we don't balance out because the reference value changed. It started out at $200, but when we subtracted the 20, the reference value was only $180. Let's go on to our next example. A stockbroker said that your stock fell 60%, but then it raised up 75%. So now you are 15% ahead in your stock, right? Well, let's figure it out. Now, it didn't tell us how much we had, so we're just going to guess. Put down a number. 1,000 sounds good. It has lots of zeros and a 1, so it's easy to work with. If you have to pick the number, make it easy. If I fell 60% of my 1,000, it's 0.6 of my 1,000, or a $600 loss. So if I have a $600 loss of 1,000, 1,000 minus 600 is a $400 loss. Or if you'd like to use your new tool that we just learned, the formula, 100 minus 60 is 40%. 40% times 1,000 is 400. Then we increase by 75%. So I'm going to take my 400 and increase it by 75, or 400 times 0.75 is 300. And that's my increase, or you can use your new tool, which is 100 plus 75, and do 175 times your 400. But in this case, we're going to go back to the old school way. So I increased by 300. 400 plus 300 gives me 700. Am I ahead by 15% from my original? If I had $1,000 and now I'm at 700 after my 75% increase, I am not 15% ahead. In fact, I still haven't even broken back to be even after my 60% loss. Why is this? Because the reference value changed. 60% of 1,000 dropped me much less than 75% of 400. Even though it's a bigger percent, it's a smaller number to work with. Let's try our next example. If elected, a politician claims they'll cut taxes by 20% for 3 consecutive years, thus totaling a 60% tax cut. You can use Excel or your calculator. In this case, let's go ahead and do it 1 year at a time. So the first year, let's just say you pay $1,000 in taxes. A 20% cut will be 20% of 1,000 or 200 off, which is 1,000 minus 200, or your new tax bill will be $800. Now for the second year, we have another 20% off, but now it's off of my new balance, which is $800 for my tax bill. 20% of this is $160 off, which makes my new tax bill $640. Then the third year, because I'm only paying $640 in taxes, that's my new reference value. 20% of that is $128 off. So I subtract 128 from 640, and my new bill is $512. Is that a 60% tax cut? Well, let's find the relative change. So my relative takes my difference, or the change, 1,000 minus 512 changes 488, divided by 1,000 is a cut of 48.8%, not 60. Now I know I did that a little backwards. I should have done the new value minus the old value, which is 512 minus 1,000, and then divided all of that by, and I'm going to put parentheses so I know that my order of operations means I subtract first and then divide by 1,000. But if I did that, I would get my same number except with a negative sign, which is 48.8%. Either way, it's still a tax cut. Let's move to our next example. A sale says everything is 150% off. What would it look like to buy an item that's $500? So $500, 150% is 1.5 times by 500 gives me $250. They will pay you $250, pay you to buy whatever was $500. Sound logical? No. Can something, however, be marked up 300%? Yes, easily. 300% is, as a decimal, 3. Let's just say it's $10. $10 times 3 is $30. Markup, so $10, the original, plus the markup, is now $40. A 300% markup. Can you use 200% less energy? No. It means 100% less energy means that you are using none, no energy at all. 200% less means that you're producing. Now, I do know that there are some people who say that if you have solar panels and they're producing more energy than you're using, then yeah, you can. However, most people just use the electricity that comes into their house and they aren't off-grid. So I'm going to say no on that one for most people. The next hint, don't average percentages. If you got 70% of the questions on the midterm correct and 90% of the questions on the final correct, did you average 80% of the questions correct? Not unless both tests had the exact same amount of questions. Let's go to the example to back this up. So if I have a batting average of 0.35 or 35%, that means that a person is hitting 35% of the times that he's at bat. Can we say a batter who had a 0.2 or a 20% in the first half and a 0.4 or 40% in the second half, that should be half, does this person have a 0.3 for the whole season? Let's go ahead and try it. Let's just say for the first half, they had 300 at-bats. So they are at bat 300 times. And the second half of the season, they were at bat 200 times. And in the first half, we had a 0.2. So 0.2 times the 300 at bat gives this particular player 60 hits. Then the second half, they had 0.4 and they were at bat 200 times. So 200 times 0.4 equals 80 hits. If I wanted to average these, I need to find the total number of hits. which is 140, over the total amount of times they were at bat. I had 300 at bats and 200 at bats. That's 500 at bats. That's 140 hits divided by 500 at bat, which is 0.28, not 30%. So remember, don't average the averages.